you survived day one. Welcome to day two. And I hope you liked our warming act before this session.
Yeah, Mark
Pretty cool.
Rusinovich talked about containers. So thank you for warming everyone up for our session.
All right, so first of all, thanks for joining our session. It's great, it's amazing to be at a in-person Ignite again. And thanks all for joining us online. We have a few folks ready to answer questions online. So send your questions with the QR code that is coming up right next. So I'm Vinicius, I'm a cloud advocate at Microsoft, and I'm joined today by Amy.
I'm Amy Colyer, Senior Cloud Advocate as well, working with Vinicius. And I have mostly an infrastructure background, so learning containers was actually really exciting for me because I kind of come from virtualization straight to cloud, and containers is kind of a great way to segue into that space. So it was really cool to learn from Vinicius, and I'm happy to present it to you today.
All right, so before we get started, a few things. So again, send your questions. We have SMEs online that are available thanks to the SMEs that are answering questions. This is a level 300 session on containers and Kubernetes. If you are not familiar with the things that we are talking about, feel free to send your questions. Again, these SMEs are available online to answer those. And also, all the content you are going to see in the session is going to be a blog post series on the IT Ops Talk.
Yeah.
Which is our blog, and I should know by head what the address is. So don't worry about taking pictures of YAML files, Docker files, and everything we're talking about. Everything is going to be available to you to be reusable after the session in the upcoming weeks. Sounds good?
Sounds good.
With that, let's get started. And we're talking about web workloads running on IIS and a few tips to containerize them and run your environment better with Windows containers and Azure Kubernetes Service. With that said, we wanted to start by talking about some of the challenges of managing web workloads, especially when you go at scale, and then how the Windows containers and Kubernetes are going to solve for those problems. So the first thing we wanted to talk about is SSL certificate lifecycle management. And what that means is, let's be honest, we all have been in that place where you get a phone call or someone saying, I'm trying to access your website, but there's an error showing up because the certificate expired. We've been there, right? Not only that, but your certificate expiring, just one of the problems of managing certificates for websites. You have to think about what certificate goes to what website. If you scale your instance, all those certificates, they have to match for all those instances. And then you have the life cycle of the certificate itself. How do you present that to your users, routing, and everything else. So managing certificates at scale becomes a problem.
And I was going to say, usually the person that gets the email about the cert doesn't work at the company anymore, and you're trying to call. Been there, done that. Another management challenge would be the application pools and websites. They're a great way to segregate your workloads on the same OS instance. However, once you scale out, you got to scale out IIS with the gold image, and now you're scaling out all those application pools and websites. And then also, if you choose to segregate like the VM side, if you go from one VM to more VMs, you still have that management overhead and added cost. So it could be a challenge just trying to scale out.
Yep. The next thing is a lot of websites, they have hard-coded configurations that are part of the website itself. So if you take a ASP.NET application, for example, you have a web config file, and that web config file has the configuration on what are the settings for my application, what is the connection string to my database. As you move your application from development to test to production, or if you're moving your application from on-premises to the cloud, managing those hard-coded configuration becomes a problem. And if you decide to scale up or down, you have to keep track of all of those configurations for all of those instances and all the websites and configurations for all of the instances that you're managing.
And so next up, we have horizontal scale. And as I mentioned, and as Vinicius mentioned, now you're managing all those SSL certs if you're scaling out. And they have to match and not expire. Also, if you scale all those app pools, you're managing all those app pools on the instances. And then you have to make sure if you add new nodes that they're all in the same OS version, they match, so the user experience is seamless. Furthermore, then we go into the end of support lifecycle.
Yep. So end of support is a major problem for a lot of our customers. And what it means is customers have entered this, this cycle of upgrading your servers for 2008 end of support, for example. By the time that you finish the upgrade of 2008, guess what? End of support of 2012. And I don't know how many of you realized, but Windows Server 2016 is already out of mainstream support. There's no new features coming to Windows Server 2016. And it means that you have a few years to get out of Windows Server 2016 into the next version. So this cycle of constantly upgrading your servers has become a challenge for most of our customers. We have a few options for those customers, but it's something that you have to keep up and keep track. So all of this combined becomes a massive challenge for managing web applications, and we have a few options with Windows containers to address those challenges, and it becomes easier and you have better IT practices. The demonstrations and all the solutions that we are going to talk about, they reference the architecture that you see here. Now, this architecture was chosen for simplicity, so we can show you how the things that we are talking about work. Some of the things that you are seeing here, like for example, Azure Container Registry, where you can host a container image, can be replaced by another option like Docker Hub, for example. And some of the things that are necessary for your application might not be in this architecture. For example, you might be using storage for persistent storage for the application. You might be using an Active Directory domain controller for GMSA for your Windows workloads. You might be using Azure Active Directory for pod identity. So we're not going to touch those things, but keep in mind that your application might be more complex than what we have here. It's just that we are using this architecture to reference how we solve for the problems that we just talked about. With that said, let's talk about the first one, which is solving for SSL configuration. And what we're going to use here is a new feature in Azure Kubernetes Service, or AKS, which is what I'm going to reference the service from now on, called Web Application Routing. Now, if you are deploying a web server, you want to expose HTTPS for your customers, right? For your clients to access your server or your web page. And what happens here is that we are going to use this new feature to configure everything at once for the ingress controller for your Kubernetes cluster, as well as how your nodes access the secret on Azure Key Vault, which is the certificate, to present that to your clients. So I'm going to move to my demo machine. And what you see here is I have a resource group, and I have a cluster deployed, an AKS cluster deployed, and I have an Azure Key Vault deployed as well. So what I'm going to do here is, because I already, oh, by the way, I should say, all of the demos were pre-recorded. We are also going to make those available to you. And the point here is we don't want to lose time with things that need to happen in a few minutes. So I'm going to go to Azure Cloud Shell, and I'm going to check the configuration for the cluster that I have. Since I created this cluster and I already configured when I created the cluster, I'm just showing that the add-on is enabled for this cluster. So you can see that the web application routing is showing as enabled. So I can go ahead and do the rest of the configuration. If you have a cluster already and you want to enable this, you can do that. It's just AKS update. All right, let's close the Azure Cloud Shell. I'm going to go to my cluster. And here I'm going to look at the workloads. And when I do that, you can see that I have an Nginx pod, which is basically the ingress controller that is controlling the traffic that is going into my cluster. And in the back end, I also have the Hello Web Application Routing namespace. And in that namespace, I have the pod that is hosting my application itself, which is the IIS Hello World. And I have a Key Vault IIS Hello World pod, which is basically how my nodes are going to be able to go and access the secret on Azure Key Vault. And that's managed via managed identity. So your AKS cluster has the necessary access to Azure Key Vault, right? All right, so let's take a look at the Azure Key Vault itself. I'm going to go back. I'm going to click on the Azure Key Vault. I have here certificates, and this is the certificate that I'm going to use to present to my users that are accessing the application. Now, the thing to notice here is that this is not inside of the pod. The certificate is completely irrelevant for the pod at this point, because we are presenting the certificate when we hit the ingress controller, not the pod. So the pod is completely unaware of the HTTPS traffic. I'm going to go ahead, close this one, go back to my AKS cluster. And then now let's look again at the workloads. I just want to show that I have a pod that is running here for the IIS Hello World. Takes a few seconds to load, and I have a pod down there. I can go back and look at the services. So here, the thing to notice is that because I have pods in the background, I have a service in front of them, but that service doesn't have an external IP address. The ingress controller is actually presented with an external IP address. Now, of course, because this is an Engine X ingress controller, what I want to do is I want to make sure that I'm accessing that website via the DNS name, right? So the configuration that I have here for the ingress controller, if I look at kubectl get ingress for that specific namespace, is that I have the IIS Hello World application, I have the class of web application routing, which is the add-on, I have a host, which is the DNS name that the clients are going to use to access, and the IP address that has been exposed. So now the ingress controller knows, based on the name of the site, to which pods to send the traffic to, right? Mm-hmm. So let's take a look at the what happens if I open that website. And as you can see, I have my fully customized application here, right? The point is not to talk about the application itself. The point is to say, this is HTTPS traffic being accessed by my customer, but then the certificate itself lives outside of the pod. The reason you see not secure is just because, of course, this is a fake certificate that is not trusted by the machine that I'm accessing from. But the point here is, lives outside of the pod, and if this certificate is about to expire, Azure Key Vault is going to notify me, and I can actually do all the process of renewing the certificate through Azure Key Vault. Pretty cool, right?
Yeah, that's great.
Next topic.
I love your custom website. I was hoping containers. So solving for that IIS app pool and websites management, you can run each IIS app pool in its own container, and that's OK. And you can also run multiple IIS app pools on a single container. But there are many benefits to migrating them to their individual nodes, and we're going to take a look at how that works. So in our next demo, I'm going to use the Azure Migrate app, migration app containerization to segregate my IIS app. It's definitely a design choice and not a technical limitation, so you don't have to do this, but by design, it just seems easier to manage each node individually versus all in one and impacting things. You can move as is into one container or extract into individual containers. It's up to you. So I have the awkward button to switch to demo. So here's the UI of the Azure Migrate app containerization. It's installed on a Windows server. You point it into your environment, and we've already pre-configured the application type and target, the necessary prereqs. It's pretty simple, and obviously connecting into my Azure environment, or in this case, Vinicius environment. Under Discovery Applications, you provide the server you want to. Sorry, these recordings. You point it to the server you wanted to discover the apps on, and it has now discovered 2 applications or 2 websites on my server. So I can choose to run the first one in container X and separate the other one in container Y and have them run independently. And now my configs won't impact each other. Another thing that's important to know with this UI, it builds an image for you using the Azure Container Registry and ACR task. So now you have that stored for you to use in the future. It also has deployment specs with the permissions pointed to either a new AKS cluster or an existing one. and now I have my deployment specs saved in that YAML file. So deploy containers, I can now use that YAML file to deploy extra containers from my environment.
Right, yeah, so just to point out, what Amy demonstrated is an option to make your life easier, so you can extract a website from an existing server, but you can do this by hand if you want. And if you have a more complex application, you can do that by the use of managing your Docker file and everything else, or you can use this interface and then further edit your Docker file and YAML files. All right. So let's talk about the next topic, which is solving for hard-coded configuration. So as I said at the beginning, web config specifically for ASP.NET applications is the file that you are probably familiar with if you've been managing IIS and web workloads for Microsoft. It's not just that. Any hard-coded configuration, when you go to a container, you probably want to take those out of the container instance and put in some kind of environment variables or something that is delivered to the container when the container is actually deployed, so the container knows what to use in terms of, is it my testing environment, is it my development environment, is it my production environment, and so on. Now, for the demonstration itself, I'm going to shift this one to the demo machine. And if you're not familiar with development, if you are not familiar with Visual Studio Code, this might seem like a lot. So again, don't worry about how complex what you see in the screen is. I'm going to point out the things that you need to know specifically for the configuration of IIS websites. The point here is I have a ticket desk application, and the application itself also doesn't matter for the demonstration. What I'm going to show to you is the web config file you see here is the thing we need to change for every time that the container runs. Why we need to do that? Because if the pod goes up on the test environment, as I mentioned, we want to have a configuration. If it goes live, it needs to have a different configuration. So what we're going to do is kind of a hack to get this web config file changed. So the web config file first. So what you see here is that a web config file has things like key value pairs for application configuration and settings, like the app name, as well as the connection string for the SQL database or whatever type of database that you have. But not only that, you have sensitive things like username and password to get to that database, right? So what we are going to use is we are going to use a PowerShell script that checks for environment variables, and that those environment variables were passed to the container at deployment time. Those environment variables have the configuration like what is the connection string, what is the application settings that I want to use for my application. So whenever this script runs, it's going to check for the web config on the folder of the application, and it's also going to check for the environment variables that have the prefix that I want to use and change inside of the web config file. Now, again, the script runs, but this script is called by a startup script. So the startup script is basically a way for you to say, go run my set web config settings.ps1, and this is where the web config file lives. So that's the file that I need to change. Now, because this is a startup script, what I did was I changed the entry point of my Docker file to point to this startup script. So at the bottom of all the configuration inside of my Docker file, I have the pointer to say, run my startup script. So to this point, what we have is every container image that is built based on this Docker file is going to run a script at startup, and that script calls for the set web config settings.ps1, and that's the script that is going to check for environment variables and then change the web config file. So the container is running on testing environment, is going to use the environment variables and the connection string to the database for testing. If it goes live, it can use the production connection string. Now, this is all great for the container image. We need to pass on the environment variables now. And the way we do that is through the YAML file that actually deploys my application. So if I move forward now, I go to my ticket desk deployment.yaml, and this is a regular YAML file. It deploys the image that you see up there. But then after that, it tells what are the environment variables that I want to pass on to the pods that are going to be created based on this deployment. Okay? So you can see that I have my application name, I have the connection string for my database, but all of these, they are actually stored in a secret way. And Kubernetes has a component called secrets, right? So you don't expose sensitive things like usernames and password. Now, I'm using that, but I'm using a secret provider in this case. And what that means is that the secret provider is going to use Azure Key Vault. So the information is stored in a confidential way, so I can have the configurations for all of my environments on Azure Key Vault. And then when I deploy my application, I pass on what are the environment variables that need to be matched for the specific environment that they are going to. So just to sum up, we have the information on Azure Key Vault. At deployment time, we pass on the environment variables. When the pod is started, there's a script that changes the web config file, checking for all the configuration that I passed on at deployment time. Does that make sense? All right, great. So next topic.
All right. So our next challenge, solving for horizontal scale and fixing that with using containers. As you can see in this this slide, nodes can automatically be scaled up and down to meet demand, but AKS is actually a VM on a virtual machine scale set. So based on resource utilization, it'll add a node, and it can also decrease your nodes in the solution. Keep in mind, though, that Kubernetes is actually, it uses metrics to schedule pods. So it can schedule pods up and down, and AKS can scale those nodes up and down to meet demand. And if the case of the pod not being able to be scheduled, it can kick up nodes as well. So in this next demo, I'm going to show how AKS scales nodes up and down with pod scheduling, according to pod scheduling. So here we are in the AKS cluster again. We click into the node pools, and we're going to see the Windows Server pool only has about one node running right now. And then if you go to the scale node pool, you can see auto scale is already set and recommended. I have a node count range of 1 and as a minimum and 10 as a maximum. So depending on demand, it would scale up to 10 nodes. But in this case, I set the nodes to only be able to run one pod, so we can show this in action. So we're going to close out. I'm going to open the Cloud Shell, my YAML file, and change one replica to 6 to kind of look like we need that demand, and it'll create those nodes for me. So now I'm going to go to my Cloud Shell to update that YAML file. So you can just upload it right here. And I run kubectl apply, the file name, and into that namespace that Vinicius had created, and now it's been configured. And now if I run kubectl get pod, it's going to see if those pods are running yet. Obviously, we still have the first one running that was upon deployment, but now you see there are 6 pending already. And if we go back up into the pool, you can see it's still running 1, but that node count is now up to 6. And we'll go back. So AKS is now going, hey, need more nodes. Let's spin up nodes. So we're going to do the kubectl get pod again. And now you can see one's already in the state of container creating versus pending. And we'll speed things up too. But if we add this watch flag, you can continue to watch the status. So pending, container creating, now some are running. It's a good way to keep status on your pods that are coming up. And then if we fast forward here, we're going to see that all 6 are running now. So it takes a bit, but for the sake of time, all 6 nodes are running, and you can see in the UI, it's already showing running 6 nodes. And what's important now is it'll scale down if I need it. If I don't need to be there for it to scale up to 10, so it's automatically based on demand. And that's it, Vinicius.
Awesome. We just released well, a few weeks ago, we just released the case study of Forza 5 on Xbox that is using Windows containers on AKS, and that was one of the main things that they used. They have not only metrics, but also node autoscale to go up to the millions of users that were using at the same time during the launch. There's technically a story that they went out to lunch when that happened. I don't necessarily trust them, but that's what they said, that they didn't have to worry about the infrastructure, the underlying infrastructure, because auto-manage was actually in place to bring up new nodes because of all the scale that they were going to achieve with the launch of Forza 5. So it's pretty cool. All right, so our next topic is solving for end of support. So here's the thing. Everything we talked about, the SSL certificate, the hard code configuration, your app pools, and your horizontal scale, they are all solved pretty much together. The first three, the SSL certificate, the app pools, and websites, as well as hard-coded configuration, because we solved those problems, we now can work on horizontal scale, right? Because you can scale up and down without worrying about the configuration of your pods. Everything is outside of the pod, so scaling up or down is just a fact of giving more pods or taking pods out. The next thing is, because now the workload is agnostic to the configuration itself, the process of upgrading from one OS to the next is just a matter of verifying, does my workload runs fine inside the new OS, the new version of the operating system? And if there are no .NET breaking changes, then just updating the OS should be good, as well as any other framework that you might be using. So here we're going to demonstrate how to do that in AKS with the point that your Docker file is the place where you change the from statement. So once you do that, pretty much what you have to do is you run your container. Does the application works? Great. So now let's go to Azure Kubernetes Service to see how that is that's performed. All right, so here we are in my Kotoso demo again, my cluster. I'm gonna go to node pools. You can see that I have a Windows Server 2019 node pool. And what I'm gonna do is I'm gonna use the Cloud Shell to check more details on the nodes. So I have kubectl get nodes. And this will show me that I have 2 Windows Server 2019 nodes supporting this node pool. If I look at pods, you can see that I have 2 pods for my application, and those pods were deployed on the 2 Windows Server 2019 nodes. If I look at the service, I have a load balancer service here with an external IP address. So if I take that IP and go to the browser, I have, again, my custom application up and running here. What I'm going to do now is I'm going to go check, I'm going to use a command here on the Azure CLI or Azure Cloud Shell to say, add a new node pool to the existing cluster. So remember, I already have 2 Windows Server 2019 nodes. I want to add 2 more in a different node pool. So node pools, they need to be version specific, right? So what I'm doing is I'm adding a new node pool, but the thing to notice is the OS SKU at the bottom. And that OS SKU is what tells AKS to deploy the node pool as Windows Server 2022. So I can upgrade my workloads. So I'm going to do that. As you can see, it was deployed. So what I can do now is I can run again kubectl get nodes. And now, oh, that was really fast, faster than I wanted. kubectl get nodes. And you can see that I have 2 Windows Server 2019 and 2 Windows Server 2022 nodes. They are in different node pools, but they are all available for this AKS cluster, okay? So now what I can do is I can go to my YAML file that deploys the application. Again, first, you need to go to your Docker file, change the from statement to make sure your application is running on the latest version. But now I can change the image version on my YAML file. In this case, I'm just changing to an IIS 2022. But you would use your custom container image. The next thing here is that Windows applications on Kubernetes, they use a node selector. And what the node selector is a way for you to say, this is a Windows application. Those pods cannot be scheduled on a Linux node, right? However, because Windows images, they have to match the version of the host, if I keep this node selector here, what Kubernetes is going to do is basically say, take this pod that's running Windows and run on one of those 4 nodes that I have. And I cannot let this 2022 image run on a 2019 node, because that's going to break the pod, right? So what I'm going to do is I'm going to change the default node selector from Kubernetes to the Azure one to use the OS queue that I pointed to in the previous step when I created the node pool. So now, these containers can only be scheduled on Windows Server 2022 nodes, not any Windows server running on this AKS cluster. Okay? So now I can go to my Cloud Shell again. I'm going to upload the file that I just saved. I'm going to type kubectl, apply the file that I want to use, IIS sample. Notice that the service didn't change, but then the IIS deployment was configured. So kubectl get pods. And here's the interesting thing. You'll notice that I ran a few times to see if the status changed, but I added the watch flag. But then what you see here is that I had 2 pods running for this application already. And when I deployed the new file with the updated configuration, the 2 pods that were running continue to run because the new one is not finished scheduled, right? So until that new pod is up and running, the older ones are not terminated because they are serving customers or clients that are accessing my website, right? So with the watch flag, you can see that there's a bunch of status changes here, and you can see that the old pods were terminated. So if I remove the watch flag now, basically what I have is the 2 new pods that are running. And notice the node name that says AKS WS, Windows Server 2022, which is the naming convention that I used for my node pool. So those pods are running 2022 images on 2022 nodes. If I go to the website and update the page, the website is still the same. The application did not change. What changed was the underlying version of the operating system, but that was way easier than opening VMs, upgrading the operating system and everything else, which is a process that you are probably familiar with.
And no downtime.
Yes, and no time for
That's
the
exciting too.
Yes. Pretty cool, right? Pretty cool.
Good job.
All right, so that was a demo number 5 of the session called 5 chips for containerizing your IIS workloads, right?
Maybe.
Oh, wait. There's one more thing. We have another demo for you.
Because we know you love demos.
So this is a demo-heavy session. We have another demo coming for you. So here's the thing. I mentioned the fact that when you upgrade a website from Windows Server, whatever version, to the next one, you have to change your Docker file, right? Thank you. That process, depending on how complex your application is, consists of opening the Docker file, making the configuration, build your container image, deploy, test the application, it fails. Go back to your Docker file, change the Docker file, build your container image, run the container, test the application, it fails. Go back to your Docker file, change the configuration, build your container, you got it,
Yeah.
right?
Sounds fun.
So it's a tedious process of going back and forth to make sure that the application is running as it should inside of the container. Now, let me ask a question. If you have to manage an IIS instance, what do you do? And it's not IIS reset. You open the MMC, right? Yeah. It's 2020 and we're still using MMCs, right? To remote manage your web servers,
sure.
Right? What about a container? Can I remote manage a live instance of a container with with the MMC for IIS?
No.
Yes. Let's show you how to do that. So that solves the problem of going back and forth. You can do this once, and then when you have it configured, you can go ahead and finish your Docker file and everything else. So what I'm going to do is I'm going to move to my demo machine, and here I have the Docker file that I'm using to build just an IIS image. So I'm starting with a from statement saying this is a IIS image for 2022, and this could be whatever other image that you might want to use from the .NET framework or ESP.NET. But the main thing are the PowerShell commands that I'm running after that. And you can add that portion of my Docker file in yours on testing environments. Don't do this in production, by the way. To basically say, during testing, I want to enable remote management for IIS. So what I'm doing here is I'm running the install Windows feature for the web management service. I'm changing the registry to enable that. And then I'm setting up the service as automatic. That's very simple. You would do that probably in a next finish kind of fashion. If you were operating a VM, it's just that we changed to a PowerShell script, and that's now part of my Docker file. So with that, I can go to Docker desktop, and I built the image already based on that Docker file. And at the top, you see that I have the IIS remote, which is the name that I gave to this image. The next thing I want to do is I want to open the port 8172, if I remember correctly, yeah, which is the port for remote management of IIS for the MMC. And that's pretty much it. I can run the container. When the container is running, I can select the option here to view the details of that specific container. And Docker Desktop has a nice feature of opening a console directly to the running container. So in this case, I can simply type ipconfig. I check the IP address of that running container. I can then go and voila, IIS MMC console. So I type the IP address, the username that can access that instance, and you have to add that to your Docker file, by the way. There's an error for the certificate, but that's fine because it's remote management. And there you go. This container is now being managed via IIS UI that you are familiar with for years and years.
That's
right?
That's awesome.
So I could come here and say, I want to add binding for the HTTPS. I want to change the basic settings of my application to change the application pool, for example. I can create new application pools. I can do whatever I want with this image. And you have two choices. You can translate those steps into PowerShell and then put those steps in a way that you can convey on a Docker file. Or don't let anyone know that I told you this, but you can simply commit the image and create a new image based on that running instance. Don't do that. Just change your Docker
It's enabled by default.
All right. You like that? Pretty cool, right? That will probably help in the process of bringing your IIS instances to Windows containers. So with that, we have a few resources for you to get started. The Windows Container Docs is the main one, aka.ms/containers. The thing to point in that documentation is actually the third link, which is the lift and shift doc, which was a humongous amount of work from a lot of people internally, bringing all their knowledge together on what you need to know as a customer on going through the process of containerizing an existing application. Internally, this was a 17 pages long doc that we put out in Microsoft Docs that you can now consume and know what are the things you should be aware of when you go and containerize your own application. That applies for web applications as well as other types of applications. Azure Migrate, as Amy mentioned before, we have app containerization from Azure Migrate that can extract applications from running servers, so you can have that deployed as a container on AKS or app service even. And the Windows Container Demos. So the Ticket Desk application that I mentioned in one of the demos is part of that repo. all of the YAML files, sample applications, how do you connect to Azure Key Vault, what do you need to know about deploying a Windows application. They are all part of the demos. We have 3 demos in there, 2 for server core, for existing apps that are being deployed now in containers, and 1 on Nano Server for a net new application that was deployed directly in the Nano Server image to save some space, but also using some new frameworks and not .NET framework.
Yeah, and that was a great way for me to ramp up going through those demos. And when you're starting from the ground up, I'm like, okay, kubectl, kubectl. That's the I joke about.
kubectl or
kubectl.
kubectl. Kubectl is much better.
You can make plushies, kubectl. Come on. Nobody. No. All right, I'm outvoted. All right, well, thank you so much.
Thank you so much for joining our sessions. We'll be around if you have any additional questions. And thank you for the folks online as well.
Yeah, thanks so much. We really appreciate it.